Hey everyone, in this video we're going to be focusing on section 8.2 in your textbook and looking at the law of sines. You may have seen this possibly in geometry back in the day if you have some recollection of it. The law of sines is a way that we're going to be solving triangles, and in particular triangles that are not necessarily right triangles. So this is going to be used when we have not necessarily a right triangle. Right triangles are great. They make things a lot easier on us because we can use the Pythagorean theorem. However, if we have a triangle that's not a right triangle, we can't always just use the Pythagorean theorem to find a missing side or something like that. So this is used in situations where it's not necessarily a right triangle. The actual law, the law of sines, is pretty straightforward. It looks like this. It says that the sine of big A over little a equals the sine of big B over little b, which also equals the sine of big C over little c. And what this is saying is if we have any triangle, draw it here, and I were to label the angles, we'll call this one A, we'll call this one B, and this one C. And then across from these angles, we call the sides little a over here, little b down here because it's across from big B, and little c. If I were to take the ratio of the angle over the side opposite, it would be equal to any other angle over the ratio of the angle with the sine over the side opposite, which would be equal to any other sine of the angle over the opposite side. So this is really useful, and I'll show you why in this first example here. So it's going to give us a triangle. Here it says we have triangle EFG. So I'm going to actually just sketch it really quick. EFG. And I would recommend doing this on every problem, even if it seems tedious. Just go ahead and do it. So we got EFG. And also remember that as we're labeling, just to be consistent, the little letter goes opposite of the big letter. So for instance, little f is going to be down here, and that equals 61. Big F is the angle we're going to write in here, 79 degrees. And big G is 34 degrees. Okay. So in using this law of sines, the letters are going to be different. We obviously don't have A's, B's, and C's, but the concept is the same. We can use the fact that we know a pair. We know a big F and a little f, right? So we're going to use that, and that's going to be sort of our baseline starting point. We're going to write the sine of the big F, so the sine of 79, over the side opposite, little f there, over 61, equals, and now we're asked to find G. That's our goal, is to find little g. Little g is over here opposite of big G. So we obviously want to, if we're going to find little g, then we need little g involved in it, so it's going to go on the bottom down here. And we need to put above it the sine of big G, which is there 34. And now this is going to work. This is going to allow us to solve this equation because we only have one unknown variable. And all of these, if you're going to end up solving it, you can only have one unknown variable, or else you're never going to accomplish anything. So we do have our three pieces of information that we're given, and we have one unknown variable. So now it's just a matter of solving using cross multiplication and then solving for the g. So if you were to multiply across there, we're going to get the sine 79g, I'm just going to write it like that, equals, multiply this way, 61 sine 34. Now don't actually type anything into your calculator to the very last step. Otherwise you'll lose a lot of decimal places. Okay, now we just need to get the g by itself. So we're going to just divide both sides by the sine of 79. And that is going to be our answer we're going to type into our calculator. So that was a bad choice of color there. So we're just going to type in 61 sine 34. Also just double check here, make sure you are in degree mode, or else you'll get the wrong answer. So hit mode and go over to degrees. So do 61 sine 34. Enter. I would just hit enter on that, and then I just leave that on there, divided by sine 79. and you should get 34.749. It tells us to round to the nearest 10th place when we type this in. So that means we look there at the 7. Next to it is a 4, so we do not round up. So that's going to be 34.7. And that seems like seems reasonable-ish, right? Big F would have a bigger side opposite. Little g is big G is a smaller angle. So we'd expect little g to be a smaller side. So let's go ahead and type this in. And boom. All right. So again, let's go ahead and do another one of these. There, we have different variables. Doesn't matter. We're just going to draw a triangle and label it accordingly. So in this one, it says we have triangle NOP. So I'm just going to draw a triangle and go ahead and just label it NOP. And if you wanted to, you could even just go ahead and write in all the little things that you need. Big P opposite of that is little p, opposite of big O is little o, opposite of big N is little n. Okay, and then the information that it gives us, it says big O, or actually a big P, a little p first. Little p is 85. It's 85, right? Big O is 57 degrees. Big P is 113. And we're asked to find little o. We'll want to know this one here. So the first thing that we always want to make sure that we have is that we have a pair. We got a pair that we know both. We know a little p and we know big P. So always circle that, figure that out first because we need a pair where we know both of them. That's going to be our starting spot. So we got sine of 113 over 85. That's going to be our known pair. We got to have that to start or else this is not going to go anywhere. So then we got to figure out, well, what do we want to find out? It's a little o, and we got to make sure we have the angle opposite of that. And we do. We have big O, so that's good. So that's going to be equal to the sine of big O, which is 57, over little o. We then will just do our cross multiplication to solve. So I just do sine of 113 O equals 85 sine 57. To get the O by itself, all we do is divide on both sides by the sine of 113. And evaluate that into our calculator. Again, we just type in 85 sine 57, hit enter, and then divide it by sine of 113. And we get 77.4. And that does seem reasonable. The other one was 85, so 77.4 definitely does seem reasonable. All right, let's see if we can get any other ones here. I think they're all going to be very similar. I just want to double check here. All right, this one is good. Okay. This one is just slightly different. So I do want to show you one like this. On the surface, we don't have what we need for this one, but we can definitely figure it out. All right, so we're going to start by still just drawing this triangle. This is triangle STU. STU. And again, if you want to go ahead and label, you could put little s over here, little t here, and little u here. And then let's write in the information it gives us. It says little s is 36. Big T is 58 degrees. Big U is 68 degrees. So the first thing that we always do is we try to figure out, well, where's our pair that we know both of them? And that's where this becomes a problem because there is no pair where we know both. We know little s, but we don't know big S. We know big T, but we don't know little t. We know big U, but we don't know little u. And we're supposed to find little u. Okay, so we know we're not going to get the u, but somehow we've either got to find out what little t is or what big S is because we need a pair where we know both of them. Turns out it's not that hard to find what we're looking for. because we're given these two angles, we can actually figure out big S really easily. Because if you know two angles of any triangle, well, you can find the third by just knowing that all triangles have 180 degrees. It's called the triangle sum theorem, right? All the angles add together to equal 180. So all we need to do to find big S is just do 180 minus 68 minus 58. And that will give us big S. So there's just one little step we got to do beforehand to get there. So that gives us big S, which is 54. And now we have a pair because we got big S and little s. So then let's go ahead and write our ratio. It's going to be the sine of our big S, which is 54, over little s, which is 36, equals, now we're trying to find little u, so we need big U. So sine of big U, which is 68, over little u. We then do our cross multiplication. Sine of 54 times u, sine of 54u, equals 36 sine 68. To get the u by itself, we then just divide by the sine of 54 on both sides. And we'll type all that in to get u. So 36 sine of 68. Enter, divided by sine 54. Enter, 41.25, so 41.3. So this is just an example of where there's one extra step. All of these are doable. You just, oops, what did I do wrong here? Apparently I was supposed to round to the nearest whole number on that one. I did just assume they were all the same. It says the nearest centimeter. So make sure you check the rounding. That one you weren't supposed to do the nearest tenth. I hate it when they mix that up on you, so don't make that mistake. I guess you guys normally have 2 tries, so hopefully you can figure that out if that was the mistake. But you can see down here they wanted the nearest centimeter, which is 41, and I put 41.3. So. All right. This is another one. So this one, you can always tell where you're going to have to find the third angle or not. Just from the outset, this one gives you little r and big R, so it's already ready to go. Honestly, even without drawing it, you could just set this one up. Sine of big R, right, which is 21, over little r, 4.9, equals the sine of big P, 104, over little p, which we don't know. And there you've got your angle set up. It just becomes a little bit more challenging if it doesn't give you pairs for all of them. So definitely a good idea to at least draw the triangle on some of them to make sure you're understanding what you're doing here. But after you get the hang of it, you really can tell just based on the information given. So, all right, that is about it. Let's try, have you tried this last one on your own here? Let's do a new problem. And have you guys just do this one on your own. So go ahead and give that one a shot. Okay, so for your answer here, if you did draw the triangle GHI, little h is over here, which is 300. Big G is 30 degrees. Big H there is 29 degrees. And we're asked to find little I. Okay, so this one we do have to do a little bit of work here. Little I is going to be here, which means we need to know big I first of all. So we got to do big I is 180 minus 29 minus 30. And when we do that, we're going to get 121 for big I. So we're going to choose the 2 that we know, which are the h's. We're going to do the sine of big H, which is 29, over little h of 300, equals the sine of big I, which is 121, over little I. We then do our cross multiplication. Sine of 29 little I equals 300 sine of 121. And then we divide both sides by the sine of 29 to get little I, which, drumroll, 300 sine 121 divided by the sine of 29 is 530.4, but it does say the nearest inch, so 530. We'll make that mistake again. 530. Boom, boom. All right, good luck, guys.